Q51. A data engineer is updating a delta table in a retail analytics system. The incoming data contains a mix of new and existing records, and the engineer must ensure that duplicate entries are avoided by updating existing rows and inserting only new ones. The engineer is deciding between using the merge into command or the insert into command. In which situation should the engineer choose merge into over insert into? A. When the data needs to be moved to a different storage path. B. When the destination is a table stored outside the managed environment. C. When the incoming dataset is in a non-delta format. D. When the destination table must avoid repeated entries during updates. The correct answer is D. When the destination table must avoid repeated entries during updates. Why this is correct: the merge into command in Delta Lake provides upsert capabilities. This means it can atomically update existing records when they match a specific condition and insert new records when they do not match. By using merge into, the engineer can ensure that row keys or unique records from the incoming dataset do not create duplicate, repeated entries in the destination table if they already exist. On the other hand, insert into unconditionally appends every row from the source, which would inevitably result in duplicates for any records that were already present. Why other options are incorrect? A is incorrect. Neither merge into nor insert into is used to relocate or move the physical storage path of an existing table. B is incorrect. Both commands can be run against external, unmanaged tables as long as those tables are backed by the Delta Lake format. C is incorrect. The format of the incoming source dataset does not determine whether you should use merge or insert logic. You can read non-delta source data, like CSV or Parquet, into a temporary view and then use either merge into or insert into to load it into the destination delta table. Q52. A data engineer is writing a Python script to validate weekly data submissions. They want a final block of code to run only if the variable day_of_week equals 1 and the variable review_period is true. To enforce this condition, the engineer needs to choose the correct control flow statement to begin the conditional block. Which control flow statement should the engineer use to start this block? A. If day_of_week equals 1 and review_period. B. If day_of_week equals 1 and review_period equals true. C. If day_of_week equals 1 and review_period equals true. D. If day_week equals 1 and review_period. The correct answer is D. If day_week equals 1 and review_period. Why this is correct: in Python, conditional blocks are initiated using the if statement, and multiple conditions are combined using the Boolean operator AND. Equality checking, equal sign. To compare if a variable is equal to a value, Python uses a double equal sign, equal smiley face. Implicit Boolean evaluation. Since review_period is already a Boolean variable true, you do not need to explicitly write equals true. Simply writing and review_period evaluates whether that variable is true. The syntax exactly matches Python's standard control flow rules. Python, if day_week equals 1 and review_period. Hashtag code runs only if both conditions are met. Why other options are incorrect? A is incorrect. It uses a single equal sign, equal symbol, which is the assignment operator in Python, used to assign a value to a variable. Using a single equal sign inside an if statement will trigger a syntax error. B is incorrect. It also incorrectly uses the assignment operator, equal sign. Furthermore, it evaluates review_period against the string true instead of the actual Boolean value true. C is incorrect. This is completely malformed Python syntax. It uses an ampersand symbol, which is a bitwise operator rather than a logical. Q53. An enterprise analytics team is struggling with SILP data architecture's separate systems for reporting, machine learning, and real-time analytics. They want to simplify and unify these fragmented setups into a single platform that supports diverse use cases without duplicating infrastructure. You need to identify the most suitable solution. What could be used to simplify and unify siloed data architectures that are specialized for specific use cases? A. Delta Lake. B. Data Lake. C. Data Warehouse. D. Data Lakehouse. The correct answer is D. Data Lakehouse. Why this is correct. The Data Lakehouse architecture is designed specifically to bridge the gap between traditional data warehouses, optimized for SQL and reporting, and data lakes, optimized for unstructured data and machine learning. By combining the cost-effective, scalable storage of a data lake with the ACID transactions, schema enforcement, and data governance features of a data warehouse, a lakehouse unifies BI, data engineering, data science, and real-time streaming analytics onto a single, open platform. This eliminates fragmented, siloed environments and prevents unnecessary infrastructure duplication. Why other options are incorrect? A is incorrect. While Delta Lake is a foundational open-source storage layer that enables ACID transactions on a data lake, it is a specific storage format technology rather than the overall architectural paradigm, the lakehouse, that addresses the entire unified ecosystem. B is incorrect. A traditional data lake is highly scalable for unstructured data and machine learning workloads, but it lacks the efficient query performance, ACID transaction guarantees, and structured indexing required for low-latency BI and enterprise reporting. C is incorrect. A traditional data warehouse excels at structured BI and reporting, but struggles with real-time streaming integration and cannot native or cost-effectively process raw, unstructured/semi-structured data for advanced machine learning use cases. Q44. A data engineer manages a Databricks job that executes multiple tasks every night. They've observed that each task experiences delays due to slow cluster startup times. To improve performance, the engineer wants to optimize how clusters are provisioned for the job using the cluster pool feature. Which action can the data engineer perform to improve the startup time for the clusters used for the job? A. Utilize endpoints provided by Databricks SQL to execute the tasks. B. Replace all-purpose clusters with jobs clusters for running the tasks. C. Set the clusters to auto-scale in response to increasing data volume. D. Assign clusters that originate from a cluster pool to reduce startup delay. The correct answer is C. Records that violate the expectation are excluded from the target dataset and logged as invalid in the event log. Why this is correct. In Delta Live Tables DLT, the on-violation drop row policy instructs a pipeline to handle data quality failures strictly by filtering out the invalid records. Target dataset. Any record that violates a defined expectation, in this case, having a timestamp older than 2021, is dropped and excluded from the final table. Tracking/metrics. Even though the rows are dropped, DLT logs a validation failure metrics inside the pipeline's event log. This allows engineers to track the exact number of passing and failing records over time without failing the actual pipeline execution. Why other options are incorrect? A is incorrect. The pipeline would only fail if the engineer used the on-violation fail update policy. B and D are incorrect. The records are completely removed from the target dataset. They are not preserved or loaded into the final table with an added flag or invalid status. Preserving the row while logging the error is a default behavior when no explicit on-violation action is specified. Q55. A data engineer is working in a PySpark notebook and has a Python variable named table_name that holds the name of a delta table. They want to run the query using table name to select customer_ID and spend columns. The engineer is constructing a dynamic SQL query using f-string formatting and needs to choose the correct method to execute it. Which method should be used to run the query using table name? A. Spark.delta.sql. B. Spark.sql. C. Spark.table. D. Butils.sql. The correct answer is B. Spark.sql. Why this is correct. In Databricks and PySpark, the Spark.sql method is a standard programmatic interface used to execute arbitrary SQL queries directly within a Python environment. By combining it with Python's f-string syntax, You can dynamically inject the value of the table underscore name variable into the SQL string. Spark will evaluate the string and return the results as a data frame. Python, table underscore name equals customer underscore transactions. Hashtag executing the dynamic query string. df equals spark.sql. F, select customer underscore ID. Spend from table underscore name. Y other options are incorrect. A is incorrect. Spark.delta.sql does not exist in the PySpark or Delta Lake APIs. C is incorrect. While spark.table, table underscore name, is a valid PySpark command. It loads the entire table as a data frame. It cannot accept a raw SQL query string containing select customer underscore ID, spend. To get specific columns using this method, you would have to append a programmatic data frame transformation like spark.table, table underscore name, .select, customer underscore ID, spend. .d is incorrect. Butyl's Databricks Utilities is an API used for file system operations, Butyl's.fs, secrets management, Butyl's.secrets, and workflow chaining, Butyl's.notebook, but does not have a .sql method for querying data tables. Q56. A data engineer is reviewing the storage layer of a Delta Lake table used in production pipeline. To optimize performance and understand how data is physically stored, they want to identify the file format used for storing Delta Lake table content. Which file format is used for storing Delta Lake table? A. CSV, B. Parquet, C. JSON, D. Delta. The correct answer is B. Parquet. Why this is correct? Apache Parquet is the underlying data storage format for all Delta Lake tables. When you write data into a Delta table, the raw data records are physically written to the storage layer, such as AWS S3, Azure AWS, or Google Cloud Storage, as highly compressed columnar.parquet files. Delta Lake add an ACID transaction log layer, stored in A_Delta_log subfolder containing JSON files. On top of these Parquet files, the track changes, but the actual table content itself resides entirely in Parquet format. Y other options are incorrect. A is incorrect. CSV is a plain text row-based format. It lacks the advanced compression, columnar performance, and statistical metadata features required for efficient big data lakehouse analytics. C is incorrect. While JSON is heavily utilized by Delta Lake, it is only used to store the table's transaction logs, metadata, schema history, and file commits inside the _delta_log/directory. It is not used to store the actual transactional table data rows. D is incorrect. Delta is the name of the storage framework and table type, but it is not an independent file format. It is a management layer built directly on top of the open-source Apache Parquet format. Q57. An analytics engineer is configuring a Databricks SQL dashboard to refresh every hour for a business reporting pipeline. The dashboard pulls from multiple datasets and is powered by queries that rely on a shared SQL endpoint. To optimize resource usage, the engineer wants the SQL endpoint to be active only when needed and minimize its total runtime. Which strategy best supports this goal? A. Enable the auto stop setting so the SQL endpoint shuts down when idle. B. Use a different SQL endpoint for the dashboard than the one used by its queries. C. Lower the cluster size of the SQL endpoint to reduce resource consumption. D. Align the dashboard SQL endpoint with the endpoints used by its queries. Q58. A data engineering team is designing a pipeline to ingest files from cloud storage into Databricks with minimal latency and automatic file detection. They want to ensure the ingestion method they choose is always compatible with their workload type. Which type of workload is guaranteed to work with autoloader? A. Streaming workloads. B. Machine learning workloads. C. Serverless workloads. D. Batch workloads. Q59. A data engineer is validating the integrity of customer records in a Spark SQL table named my_table. To assess data completeness, they need to calculate how many entries in the member_ID column are null. Which command should they use to get this count? A. Select count member_ID from my_table. B. Select count member_ID, count_null member_ID from my_table. C. Select count if member_ID is null from my_table. D. Select null member_ID from my_table. The correct answer is C. Select count if member_ID is null from my_table. Why this is correct? In Spark SQL, the count if condition function evaluates a Boolean condition for each row in a dataset and returns the total number of times that condition evaluates to true. By passing the condition member_ID is null, Spark SQL checks every record, determines if it is null, and increments the counter accordingly. This provides the exact count of missing or null entries in that specific column. An alternative standard SQL approach is select count from my_table where member_ID is null. But among the given multi-choice options, count is the correct and most elegant built-in function to accomplish this in a single select statement. Why other options are incorrect? A is incorrect. The standard count column_name function explicitly ignores null values. Running this command will return the count of rows where member_ID is not null. B is incorrect. There is no built-in Spark SQL function named count_null. This syntax will result in a compilation/analysis error that D is incorrect. There is no null function in Spark SQL used for counting records. This syntax is invalid. Q60. You are an enterprise software engineer building a data processing application on your laptop using a local IDE. After setting up Databricks Connect, you execute your PySpark scripts locally. You observe that heavy data frame transformations are processed on the remote compute resources, yet output commands such as .show print the evaluated records straight into your local terminal. What fundamental architectural concept does this workflow demonstrate regarding how Databricks Connect operates? A. It demands manual synchronization of the evaluated outputs from the remote infrastructure. B. It executes all Spark compute on your local hardware and exclusively accesses remote files. C. It proxies Spark commands from your local development environment over to the remote cluster. D. It mirrors the complete remote cluster environment locally onto the engineer's workstation.